Hello and welcome to our second stream. Today we're doing a maths paper. So as you can see here, this is the Edexcel 2018 paper 2. So this is a calculator paper, and we chose Edexcel basically because it's one, the most common exam board, and two, it's pretty similar to all the other exam boards. So if you're doing AQA or OCR or International Edexcel, this is still basically going to be perfect for you. So the plan today is basically to go through this entire paper as I would if I was doing it, and I'll explain my reasoning and my thoughts behind each question, but I'm not going to explain the entire topic of each question because that would just take forever. So yeah, with that out of the way, we'll get started. If you have any questions and you're watching it live, then do let us know. And whether you're watching it live or not, I think the best way to do it is to pause the video whenever you go into a new question, have a go at it yourself, then press play and see how I work through it. That would definitely be the best, most useful way to use it. So with that out of the way, let's take a look at question 1. So question 1 here, we've got parts A, B, and C. And these are basically testing your power rules. So testing whether you know what to do with these powers or indices. So in part A here, we have m to the power of 3 times m to the power of 4. And when you multiply things like this, that have the same base, so both have m, then you add the powers. So for this one, we would do m to the power of 3 add 4, which is m to the power of 7. And that's it, that's the answer. Also, I want to say that of course, in exams, you need to show every line of working. There might be a couple of cases, in this case, where I don't write everything, just because my handwriting is really messy and it takes ages. But make sure in the exam you do write every line of working. Okay, so for this next one, for part B, we need to simplify 5np cubed all to the power of 3. So we've got a bracket all to the power of 3. And when we have this, you have to apply this power to everything inside. So if we apply the 3, the power of 3 to the 5, that will give us 5 cubed. Apply it to the n, we get n cubed. And if we apply it to the p cubed term, it's basically just p cubed cubed. So for 5 cubed, that just means 5 times 5 times 5. 5 times 5 is 25, times 5 again is 125. But remember, you have a calculator to work that out. N cubed doesn't change, we keep that as it is. And then here, because we have this, all to the power of something else, we have to multiply the powers. So 3 times 3, which is 9. So that will give us p to the power of 9. Okay. Then for C, we have a fraction. So all of this stuff over this stuff. And the key thing to remember with fractions is, it's just a divide. So really we're doing this top bit divided by the bottom bit. And you basically just need to look at each kind of number or letter separately. So we start with 32 divided by 4, which is 8. Then we do q to the 9 divided by q to the 3. And when you divide them like this, you've got to subtract the powers. So because 9 take away 3 is 6, we have q to the power of 6. And then for the r's, we have r to the 4 divided by r. And remember, if you just have an r by itself, or any letter by itself, it's kind of like it has a 1, a power of 1. So it's 4, take away 1 is 3. So we get r to the power of 3. And that's it for C. So, moving on to question 2a now. This one says, find the lowest common multiple of 40 and 56. And lowest common multiple, or LCM, is the same thing as the least common multiple. They call them lowest or least, can be interchangeably. Doesn't make any difference. But basically what it's asking for is, if you list out the multiples of 40 and the multiples of 56, what's the lowest number that is in both lists? The lowest number that is a multiple of both of these. And there's a couple ways to do this, but the easiest way is just to list out the multiples. So 40, add 40 is 80, add 40 again is 120, add 40 again, add 40 again, add 40 again, and so on and so on. it's hard to know how high you need to go. I normally do kind of 5 or 6 to start with. And then for 56, we do the same. So 56 add 56 is 112. Add 56 again is 168. And remember, you can do this on your calculator. Again is 224. Again is 280. And we could keep on going, but actually, if you can see, we've actually already found 280 over here. So because 280 is in both of these lists, it means it's a multiple of both of them, and it's common. It's common to both lists. So because it's the lowest common multiple, this is our answer. So we put 280. All right. So part B then. This is similar, but this time we have to find the highest common factor of A and B. We haven't been told exactly what number A and B are, but we've been given A and B in terms of their prime factors. So you can see they've written A basically as a product of these prime numbers. So if I rewrite it down here, A is basically 2 cubed, so 2 times 2 times 2 times 3 times 5. That's what they're telling me A is. So if I wanted, I could multiply all these and actually find out the number that A is, but we don't really need to care. And then B is 2 squared, so 2 times 2, times 3 times 5 squared, so times 5 times 5. Yeah. So all I've done here is I've just written them out, not using the powers basically, just written them out in full. And then for this, again, there's a couple ways to do it. What I like to do though is basically draw like a huge Venn diagram. So let's make this nice and big. Make one of them A, make one of them B. And basically we need to put all the numbers, all the 2s, 3s and 5s, somewhere in the Venn diagram. So if we look at the 2s first, A has 3 2s, B only has 2 2s. So because both A and B have 2 2s, we put 2 2s in the middle. Remember, the middle region of a Venn diagram is the region that both of them have in common. But then because A had an extra one, we can pop that over here. And because we've done these now, I would just cross all these out so we know we've covered them. And then for 3s, A has 1 3, B has 1 3, so we put 1 3 in the middle, cross those out. And then for 5s, A has 1 5, B has 2 5s, so that means 1 5 goes in the middle, because they both have 1 5 in common, and 1 goes in B. And then the final step, to find the highest common factor, all we do is multiply these numbers in the middle region. So 2 times 2 times 3 times 5. If you multiply those, that will give you the highest common factor. And if we do that, 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60. So our answer here is 60. That's the highest common factor. If you wanted to find the least common multiple, or lowest common multiple, instead of just multiplying these together, you'd also multiply them by this 2 and this 5. So you multiply all the numbers in the whole Venn diagram together if you want to find the lowest common multiple. All right, super. So let's go down here. Can I just scroll out a little bit? So, question 3. The line L is shown on the grid. So here's our grid with our line. Find the equation for L. So basically we just have to find the equation of this line. All right, so the key thing here is that whenever you think about a line equation, or particularly a straight line equation, you've got to use the form y equals mx plus c. So y equals mx plus c. And the important thing here is that m is your gradient, m is a gradient, and c is the y-intercept. So m is like how steep the line is, c is where it cuts the y-axis. So straight away, this point down here is c, because this is where my line L, crosses the y-axis. It crosses the y-axis at -6. So c is -6. M though, to work out the gradient, you have to figure out how much the line goes up by every time you go across by 1. So if we pick this point here, because this is kind of at the intersection of the x and y lines, if I go across by 1, I have to go up 1, 2, 3. So across by 1, up by 3. And that means that my gradient is 3, because I have to go 3 places up for every 1 that I go across. So m equals 3. And now that I know m and c, I just put them into the equation. So know that y is going to be m, which is 3, x, plus c, which is minus 6. So I could add negative 6, or I could just put take away 6. And that there is the equation of the line. So I would write that down here on the line. Okay, so next up, it says Rhea buys a van for £8,500 plus VAT at 20%. And if you haven't heard of VAT before, VAT is a value-added tax. It's basically a tax from the government that gets added to most purchases that we make. So whenever you buy something, you always have to add 20% on, and that's the bit that goes to the government. Most things you buy, though, already have that taken into account, so you don't have to calculate it yourself. But here, we sort of got to calculate it. So it says, Rhea pays a deposit for the van, and she then pays the rest of the cost in 12 equal payments of £531.25 each month. Find the ratio of the deposit Rhea pays to the total of the 12 equal payments. Give your answer in its simplest form. So feel free to pause the video here and have another read, it's a bit complicated. But basically, with these, I would always try to write out what we're trying to find. Before you should do any working, just write out what you're trying to find. So we're trying to find the ratio of the deposit she pays. So ratio of the deposit to the total of the 12 equal payments. So total, excuse my handwriting, of 12 payments. There we go. So that's what we're trying to find. Oops. So now we can always look at that and we're like, okay, that's our aim. And of course, to do that, to find that ratio, we're going to have to find what the deposit was, and we're going to have to find what the total of the 12 payments was. Now that might be a bit complicated, it might take a few steps, but at least we know what we're doing. So, I suppose the easiest one to start with would be to find the total of the 12 payments, because we're told that there's 12 of them, and this is how much they are each. So to find that total, I would just do 12 times £531.25. And I'm just going to pop that in the calculator. 12 times £531.25. Typed it in wrong. And that gives us £6,375. So that's how much she paid in the 12 payments. And next, we need to find the deposit. We don't know what the deposit is, though. It doesn't really tell us. But if we work out the total cost of the van, and we subtract how much she paid in the payments, the other bit must be the deposit that she paid initially. So what we're going to have to do is, first of all, work out how much the van cost. So we're going to have to do 8,500. That's meant to be a 5, that's terrible. 8,500, add 20%. And basically, if you want to add 20%, we kind of want to find 120% of it. So we can do that by doing 8,500 times 1.2. If you times something by 1.2, it means you're finding the original and also 20% extra. So we do that, and that gives us £10,200. Yeah. So that's how much she paid in total for the van. That's not the deposit yet. So to find the deposit, we're going to take this total and subtract how much she paid in the 12 equal payments. So 10,200 minus 6,375 and that gives us for the deposit £3,825. So now we basically have our ratio. We know that this here is the deposit. This here is how much you paid in the 12 equal payments. Yeah, together they add up to the total cost of the van. And we just need to find the ratio of these. This already is a ratio, but they've asked us to put it in the simplest form. So that normally means the numbers have to be as small as possible and whole numbers. So what I'd normally do is to divide them both by the smaller one. If you have a really big one like this, you can simplify it just by dividing them both by 5, and then dividing them both by like 10 or 2 or whatever else you can do. But it might be a bit of a pain here. So what I'm going to do is divide them both by the smaller number, by the 3,865. And if we do that, this will become 1, because this number divided by itself is just 1. And this one here will become 5/3. Yeah, so that's looking a bit better. It's nice and simple now, but we've got a fraction. So to make this not a fraction, I'm going to times it by 3. Yeah, because it's at the moment it's a fraction over 3. If we multiply it by 3, it'll get rid of that fraction. So 1 times 3 is 3, and 5/3 times 3 is 5. So that's our answer. The ratio is 3 to 5. So we'd pop that all the way down here, 3 to 5. Yeah. Okay. Number 5 then. So it says here, complete the table of values for y equals x squared minus x minus 6. So this here's the equation. I'm going to fill in this table. And all you do for these is you basically put each of these x values in the equation, so in the place of the x's, and that will give you the y's. So let's say that we'll do minus 2 first. So if x equals minus 2, so this one, then y will equal, instead of x here, I have minus 2 that's being squared. And instead of take away x, I'm going to take away negative 2. And I'm going to take away this 6. Yeah. So then I go back through that. Minus 2 squared is positive 4. Because if you multiply a negative number by another negative number, it gives you positive. So that's 4. Here we're going to take away negative 2. If you take away a negative number, it becomes a plus. So we're going to add 2. And then we're still going to take away the 6. And if you do that, 4 add 2 is 6, take away 6 is 0. So that overall gives us 0. So we pop 0 here. And then we do the same thing, plugging in minus 1, plug in 1, plug in 2, plug in 3. It's exactly the same method though, so I'm not going to go through it all. If I just check back, this would be minus 4, this would be 6, this would be minus 4, and this would be 0. So that's that. Yeah, so that's just filling in a table from an equation. So, oh, and also the thing to notice with this is you see it has an x squared. If it has an x squared, but no higher powers of x, that's how it's just going to be quadratic. So it'll be a kind of like smiley face curve. Okay, so for part B, so I'm just going to scroll out quite a bit here. It says, on the grid, draw the graph of y equals x squared minus x minus 6. So draw the graph that we just plotted the values for. Sorry, wrote down the values for the values of minus 3 to 3. So basically what they're saying is, take this table you just done and all the coordinates you found, plot them on the graph, and then join them up. So if we think of minus 3, 6, we go to minus 3 on the x-axis, and we go up to 6 on the y-axis. That's points just here. Then this one is minus 2, 0. So we go minus 2, and we're still at 0, so we pop that there. Minus 1, minus 4. So minus 1 is here. Go down to minus 4. Then we've got 0, 6. Oops, that's actually a bit lower than we have. So that's down here. Then we've got 1, 6. Hang on, 0, minus 6. 1. Hang on. Did I? Sorry, that's meant to be minus 6, my bad. Apologies, so 1 was actually minus 6, not positive 6. That's why that looks a bit funny. So minus 6 here. Then 2 is minus 4. And 3 is 0. So these are our points. So then we just to join them up. It's a bit hard on a tablet, to be fair, but pop that down like that. And that's something like that. Yeah, they're not normally too fussy with how you draw these graphs, as long as you go through all the points that you've put on, and it looks like roughly, it's like a curve. You can't go to any kind of sharp points. Okay. So now this one says, use your graph to find estimates of the solutions to the equation x squared minus x minus 6 equals 2. So these questions, to be honest, can be really hard. If you haven't seen them before, you don't know what they are. They are kind of really tricky. But the thing to notice is that the x squared minus x minus 6 bit, that's the graph that we just drew. And this here is almost like another graph. So you can imagine that we have y equals x squared minus x minus 6, which is the curve we drew. And then over here we have like y equals minus 2. So these are our two different equations for our two different lines. So all we have to do is plot both of these on the same graph and see where they cross. So if we scroll up, we already have the main one. So all we now have to do is plot y equals minus 2. So minus 2 is here. So y equals minus 2 would just be a line going straight across like that. Yeah. And the points where these cross is this point here and this point here. Yeah. So I just see where these are. This one here is around about, I don't know, 2.6, 2.7. Yeah, we'll say 2.6. And this one over here is about minus 1.6. Yeah. So because these are the x coordinates of the points where the lines crossed, these are our solutions. So we would just write that down here. I mean, I wouldn't have written that over the answer box. So we've got 2.6 and minus 1.6. Those are our two solutions. And that's it. But yeah, this is an unusual question, but that's how you do them. Okay, number 6. So this one says that a force of 70 newtons acts on an area of 20 centimeters squared. Then the force is increased by 10 newtons and the area is increased by 10 centimeters squared. Helen says that the pressure decreases by less than 20%. Is she correct? We have to show our working. Okay, so to work out pressure, we have to use this equation, which they've nicely given us. So basically, all we have to do here, if we think about like overall what we're going to do for this question, is find out the pressure originally, and then find out the pressure again after those changes have been made. And then we can see, has the pressure decreased by more than 20% or less than 20%? So these are our initial conditions, 70 and 20. So if we want to find out the pressure, so first, pressure is going to be force over area. So pressure equals force over area, which is going to be, the force is 70 newtons over the area of 20 square centimeters, and that gives us 3.5. You could put the units of newtons per square centimeter, but it's only out working, so we don't really need to. So that's the pressure to start with when we have these values. And then in the new scenario, if our force has been increased by 10 newtons, it won't be 70 anymore, it'll be 70 add 10, so 80 newtons. So force, or F, is 80 newtons. And our area is increased by 10. So it wouldn't be 20 centimeters squared, it'd be 30. Yeah, 20 add 10, so we've got 30. So to work out the pressure, we're going to do the force of 80 divided by the area of 30, and that gives us 2.67 newtons per square centimetre. So that's what it's decreased by. So it's gone from 3.5 down to 2.67. Yeah, so most of the questions sorted now. And we now need to see, has the pressure decreased by less than 20%? So what I would probably do here is think, we could just do what percentage, or let's decrease this by 20% and see what that is. So if we decrease by 20%, yeah, we could find 20% of this and then take it away. So 20% of 3.5. Remember, to find a percentage of something, you divide the percentage by 100. So 20 divided by 100 is 0.2. And then you multiply it by the number. So 0.2 times 3.5. Yeah, which we can put into our calculator. And that should be 0.7. And if we actually did 3.5, take away 0.7, I'll do that up here. I haven't really left enough space, have I? 3.7, 3.5 minus 0.7, that will give us 2.8 newtons. So if we decrease 3.5 newtons by 20%, it would be 2.8. And if we look at this, this is less than that. So the pressure has decreased by more than 20%. Yeah, because it's even lower than 20% would give us. So Helen is wrong because it's decreased by more than 20%. Does that make sense? And that's it. That's our question done. Probably should have laid this out a lot more clearly, but I'm trying to keep within the sort of video frame window and not go down too much. So sorry about that. Okay, so let's see what we have here. I might have to zoom out a little bit. So question 7. We've got a shape here on a grid, and it says enlarge shape A by a scale factor 1/3 from a center of 0, 1. So we've got shape A. They're asking us to enlarge it. Now, weirdly, enlarging something doesn't necessarily make it bigger. If your scale factor is less than 1, so it's a fraction like this, then actually it will get smaller. So when we enlarge this shape, it's actually going to get smaller. But we have to enlarge it from this center. So the way that I would do this is I would first of all draw some lines. Oh, that hasn't worked, I think. Okay, this is not great. I'm meant to be able to draw straight lines on here. I'm not entirely sure how. So basically draw some points from 0, 1 up to this point, and 0, 1 up to another point. We'll maybe say, let's try it with this point all the way up here. And in the exam, you'd want to use a ruler, but I'm doing this on a tablet, so I can't use a ruler. And what you want to do is basically take these lines and shorten them by a scale factor of 1/3, so make them 3 times shorter. So imagine that we start off here 1, and to get to this point up here, I have to go up by 9, and then I have to go across by 3. But if I want to do a third, 9 times a third, or 9 divided by 3, is 3. So I now only go up by 3. 1, 2, 3. And instead of going along by 3, to the right by 3, I go along by a third of that, so 1. So I go across by 1, so here. So basically this point here has moved down to here. Then if we do the same thing for this one, it's still up by 9, but this time it's across by 3, 4, 5, 6. So 6 divided by 3 is 2, so I move it across by 2. So basically this point has come to here, this point has moved from here. So the reason these guidelines are meant to be helpful, I mean if they were drawn straight they'd be helpful, is because the new point will be somewhere along the line. Yeah, so this is here, that's there. And then you can sort of just draw the rest. So instead of coming down by 3, I'm only going to come down by 1. And from here to here, instead of coming down by 6, I'm going to divide that by 3 is 2, so I'm going to come down by 2. And then I just join these up, and that's it. So here's my new shape. So there's a few different ways to do this, and if you did that differently without these guidelines, that's perfectly fine. You don't have to use them. But when you can use a ruler, they are quite helpful. But yeah, that would be our answer. Okay, so number 8. So this one says that 60 people were asked if they prefer to go on holiday in Britain or in Spain or in Italy. So we've got 3 locations, 60 people. 38 of the people were male, 11 of the 32 who said Britain were female, 8 males said Italy, 12 people said Spain. 1 of the females is chosen at random. What is the probability that this female said Spain? Okay, so in questions like this, you kind of want to notice what sort of question they are. So in this question, they've just given you loads of random little facts, and you somehow need to use that to figure out all the other information. So basically, how many males and females there are at each of the locations. A few ways to do it, but what I would do is I would set up a little grid of, let's say, males versus females, and over here we have the locations. So we can have Britain, Spain, and Italy. And then as we learn anything, we can put it into our table. So it says 38 of the people were male. So at the very bottom here, we can have like our totals column, and males, so 38 are males. So the males in Britain, Spain, and Italy must add up to 38. Then 11 of the 32 people who said Britain were female. So there's actually like 2 facts. We know 11 were female and liked Britain, so that's 11 here. And because out of 32, the total for Britain must have been 32. And actually we can figure out the males that liked Britain by doing 32, take away 11, which is 21. Then, what have we got? So 8 males said Italy, so we can put 8 males here. And you see how now the only thing left in this column is this empty square. That means we can figure this out. So we can do 38, take away 8 is 30, take away 21 is 9, so we can figure out this here should be a 9. Then 12 people said Spain, so Spain total, so over here at 12. And again, in this row now, the only empty square is this one. So 12 is the total, take away the 9 that liked Spain, sorry, the 9 males, means there's 3 females that liked Spain. And what else? So we know there's 60 in total as well, 60 people in total. So we add that. And we know that if there's 38 males and 60 in total, we can do 60 take away 38 to find there must be 22 females. And we can also do 60 take away 12 and take away 32, which would be 44, should be 16 hopefully. And then to find this last square, we can either do it going along here or down here, which in either case should give us 8. So now you've filled in the grid. To be honest, you don't always have to fill in the entire grid like this. Like often when you're halfway, you'll have all the information that you need. But sometimes it's easier just to do it all, and I kind of wanted to show you how you do it anyway. So if we look at our question, what's the probability? So one of the females is chosen at random. So it's definitely a female. And it says, what's the probability that this female said Spain? So we look just in this female column, because it says one of the females is chosen. And we're going to find what's the probability that if a female is chosen, that she would say Spain. And we see Spain is just 3 females out of 22. So we've got 3 out of 22. So now we've got to turn that into a probability. So we do 3 out of 22. So that will put it as a fraction. And to be honest, you could leave it like that, 3 out of 22. I think that's fine. You could convert it into a decimal or a percentage if you wanted to, but I think I'd just leave it like that. You can't simplify it. So that's all good. So that's it. That's the probability that a female who was picked would have said Spain. Okay, so number 9. So this says that Jean invests £12,000 into an account paying compound interest for 2 years. Remember, compound interest is the one where you earn interest on your interest, not just on the initial money that you put in. And it says in the first year, the rate of interest is X%, so some unknown percentage, we don't know. At the end of the first year, the value of her investment has gone up to this. So we can see that she's gained £336 in the first year, which must have been because of the interest that she got. In the second year, the rate of interest was X/2, so half of what it was initially. And we need to find what is the value of Jean's investment at the end of the 2 years. Okay, so we already know how much money she had at the end of the first year. So all we really need to do is add the interest that she'd get from the second year onto this, and we'd have the total. The issue with that is that we don't know what the interest rate is, because we don't know what X is. So our first step is actually to calculate X. Yeah, whenever you do a question like this and there's a few steps, always break it down and think, what am I overall trying to do? And therefore, what is my first step going to be? So first step is to find the value of X. So as we said, in the first year, her money went from 12,000 up to 12,366, 3,336, my bad. Yeah, so we can do the new one minus the old one to find that it must have increased by £336. So if I want to find out what interest rate that is, I need to find what percentage is this of the original. So to find the percentage of a number, you just do the change. The number change is 336 divided by the original times 100. Yeah, this bit here would give it to you in a decimal, but if you want it as a percentage, we times it by 100. So let me just do that on a calculator. So that gives us 2.8%. So, well, we should have said X equals, yeah? X is 2.8%, or X is 2.8. So, now that we know the first year interest was 2.8%, and we're told in the question just here that the second year of interest is X/2, like half of that. We know that in the second year it'll be 2.8 over 2, which, if you put in the calculator, is 1.4. So we know in the second year she's going to get 1.4% interest. So let's find now 1.4% of this amount then. So to do that, we just do 12,300. Hang on, I should probably write what we're doing. So let's just put a line there. So in the second year, so she'll have 1.4 is the interest rate. So if we pop that over 100, that will just convert it back to a decimal. Because once you have a decimal, you can multiply the decimal by the number, so 12,336, and that would tell you the interest rate that year. So if we do that, 1.4 divided by 100 times 12,336, the interest is £172.70. Yeah. So that's the interest, and this is how much you started with. To find the total, we just add those together. Yeah. So we do 12,336 add the 172.70. Again, we can do that on our calculator. And that gives us £12,508.70 in total. Yeah. So overall there, our first step was to find out what x was, find out what the interest rate was, using the initial amount and how much you had at the end of the first year. Then once we found x, we could find x over 2 to find the second year interest rate, and then we could add that interest onto the second year's amount to get the total. And that's it. Like with a lot of things here, there are other ways to do this. So we could have found the interest a bit simpler here. But yeah, just always be aware there's multiple ways to do each step. So if you've done something different to me, but you still got the right answer, then obviously that's perfectly fine. All right, so vectors. So it says here, the vector A and the vector B are shown on the grid. And part A says on the grid, draw and label the vector minus 2a, and then we'll have to add them together. So if you haven't done vectors yet, don't worry, these are towards the end of the course, so you might not cover them. They basically show a movement. There's no real start and end position, they just show a movement. So if we did draw and label the vector minus 2a, we can see from here that a is here, but we want minus 2a. So the minus bit means we're going to have to flip the direction. So instead of going up to the right, it'll be going down to the left. And the 2 bit means we have to multiply, we're going to make it twice as big. So instead of our line, if we just copy this out to be like that, instead of it being this big, I want it twice as big. So it's going to be extended like that. Yeah. And instead of going upwards, it's going to go the opposite way, so it's going to go downwards. So that is minus 2a. Yeah, so I'll just always do one bit at a time. And that's it, minus 2a. Then, down here, part B, it says work out a plus 2b as a column vector. So a column vector, just an example, is where you write it, well, basically you write it in something like this. So for A, you can see that A basically goes across 1 and up 2. So as a column vector, that would be 1, 2. Basically, but the change in the x at the top and the change in the y at the bottom as you go from the start of the arrow to the end. For example, for B, you go across by 1, so we're going to have a 1 at the top, but you go down by 1, 2, 3, so we're going to have a minus 3. Yeah, basically, if you go to the left, then this top number will be negative. If you go down, the bottom number will be negative. But if you're just going up and to the right, then they're positive. So we've now written out A and B, but we need to work out A add 2B. So if I just write A plus 2B, my A is 1, 2, plus 2 times B, which is 1 minus 3. And then to simplify that, all you do to sort this thing here out is you multiply 2 by each of these things inside. So I'll copy this out, it's the same. I still have 1, 2 for A, but then I do 2 times 1 to get 2, 2 times minus 3 to get minus 6, and that's what we have. And I just add them together. So now I just add the top numbers, the 1 add the 3, the 1 add the 2 to give me 3, and the 2 add minus 6, which remember is 2 take away 6, so it's actually minus 4. And that's it. We get 3 minus 4, which we should pop in here. That's it. So that's vectors for you. Yeah, if you haven't done them yet, they're a little bit tricky when you first start them, but they're really not that bad. You just got to practice lots of questions, and they're all pretty repetitive. Okay, number 11. Okay, So this one, it says f and g are functions such that f of x is 2 over x squared and g of x is 4x cubed. Yeah, so they're just given us two functions. And for part A, we need to find f of -5. So with these, basically what you do is you take this number inside here. Yeah, this is basically the x. They're saying x is -5. And you just put it in the equation. So instead of writing x here, I'm going to put the number -5. Yeah, like you can see they put f, like they're saying x, x. But now that you've got -5, you put -5 here instead. So it's going to equal 2 over -5 squared. Yeah. Which is actually 2 over -5 times -5. Remember, 5 times 5 is 25, and because they're both negatives, it will become a positive number. So it's 2 over 25. And that's it. That's the answer. Then for this one down here, we have to find fg of 1. So again, a couple of ways to do this one. I think the easiest is to first of all find out what g of 1 equals, and then we'll plug it into the f function. So to find g of 1, this is the 4x cubed one. So instead of doing 4 times x cubed, when I put the 1 in there, it's actually 4 times 1 cubed. And 1 cubed is just 1, 1 times 1 times 1. So it just becomes 4 times 1, which is just 4. Yeah, so the g of 1 is just 4. And then what you do is, because g of 1 is 4, I now have to do f of 4. Yeah, so basically imagine like we've taken this bit here, this g of 1, this bit was 4, so now I do f of 4. Yeah, so just like we did f of -5, we're now going to do f of 4, which is going to be 2 over 4 squared, which is 2 over 16. So we divide top and bottom to get 1 over 8. That's it. So fg of 1 is 1 over 8. And that's it. Okay, I'm going to zoom out a little bit here again. So question 12. So we've got these four graphs, A, B, C, and D. And it says here that the graphs of y against x, so these ones, represent 4 different types of proportionality. Match each type of proportionality in the table to the correct graph. So these are the types, based on y is proportional to x, or y is proportional to x squared, or y is proportional to root x, or 1 over x. I'm going to say which graph do each apply to. These, again, are a bit tricky if you don't just know them. I would say you just kind of want to learn them all. I'd maybe put each one on a flashcard. This, to be honest, is like the majority of the ones you have to know. So if you know these ones, you're kind of sorted. But this first one, y proportional to x. This one means that as x increases, y will increase proportionally. So we're looking for a completely straight line where they both increase together, which would be b. So this one here is b. This one here, y is proportional to x squared. This one means that as x increases, y will increase even faster because it's going up with the square of x. So this one will actually be d, because you can see that as we go off to the right, the line's getting steeper and steeper and steeper, and going up is getting quicker and quicker to rise. So that's this one, d. And this is just the opposite. So y is proportional to the square root of x. It means that as it goes to the right, it's going to get less and less steep. So this one is a. And then this one, y is proportional to 1 over x. Basically, just gives you this weird shape. It's kind of a whole topic I have to go over. But yeah, it just gives you this pretty unique shape. So just remember that. And that's C. Yeah, there's not a huge amount you can explain for these without actually going through all details of why. But yeah, that's it. Okay, number 13. What have we got here? So we've got this thing, and it says A, B, C, and D are points on the circumference of a circle with a center of O. FDE is a tangent, so like this thing here is a tangent. So that y minus x equals 90. And you've got to give a reason for each stage. So you're normally going to get one of these for each paper. One of these ones where they give you like a circle or like triangles and quadrilaterals and stuff. They give you maybe some angles but not other ones, and you have to find the missing angles. This is a little bit different, and they're not finding exact angles. It's all in algebra. It's all in terms of x and y. But it's that same type of question. And there's a whole bunch of angle rules that you have to remember, or circle theorem rules. This is a bit odd. It's usually that y minus x equals 90. And when you first look at this, I wouldn't actually worry about how this is arranged or what it's saying. All we have to do is think of a rule that includes y, x, and the 90 must come from somewhere. That's all I would think. And then once we've thought of a rule, we can just write down what we know and rearrange it into this form. So, to be fair, this uses the, well, or what I think is the kind of hardest rule to remember. The first part of the rule isn't so bad. It's basically that whenever you have a radius, which is this bit here, and then a tangent, the angle between the radius and the tangent will be 90 degrees. So this angle here is 90 degrees. Also, this angle here would be 90 degrees. Yeah. So you'd have to, in the exam, actually like, write down that rule. So you'd write, the tangent to a circle is perpendicular, or 90 degrees, to the radius. You have to write that out in like a whole sentence. So that tells us that this bit here is 90. The next rule, which is the hard one to spot, is if you take this thing here as a triangle, yeah, then this whole angle here will be the same as this angle here. Yeah, this one's always hard to spot, but basically if you have a triangle and one of the points is down here at a tangent, this angle is always equal to this angle over here. Just like this angle down here would be equal to this one. This is called the alternate segment theorem. So basically this bit here, which we knew was 90, and the x, so like the 90 plus this x, will be the same, will be equal to the y. Yeah. And for this one, you just have to state alternate segment theorem. You don't have to like put it into more words than that. So you just say, by the alternate segment theorem, 90 plus x will be equal to y. And then if you look down at this, all they've done differently is the x is on the other side. So we can do 90, take x on both sides, we get y minus x, which is the same thing as they've got. Y minus x equals 90. You can pop it around the other way if you want, but that's it. I think here there's actually another way to do it. So you don't have to use this technique as long as you get to the right answer. But yeah, that's it. It's quite hard to see the alternate segment theorem. I always get it confused. If I were you, I would just Google alternate segment theorem, and you'll see loads of examples on Google Images, and that's kind of the best way to understand it properly. Awesome. So down here for B, it says Dylan was asked to give some possible values of x and y. He said y could be 200 and x could be 110, because 200 minus 110 is 90. Is Dylan correct? So if you remember, what we just found was that y minus x equals 90. So he's saying that because y minus x is 90, y could be 200, x could be 110, and because that would 200 minus 110 would give you 90. Sounds pretty plausible. The issue though is if you scroll up and you look at y, there's no way that can be 200 degrees. This is actually, so this is definitely less than 100, well, it's definitely less than 180. Remember, 180 is like a straight line. So this is definitely less than 180. And you see that this is less than a right angle. So this has to be less than 110. So even though his values would fit the formula that we found, or the rule, they're kind of obviously not true, because just looking at this, it wouldn't make sense. So we have to say no, because y has to be less than 180 or something. Okay. So, number 14. So this one says, the distance time graph shows information about part of a car journey. Yeah, we can see the graph here. We've got time on the x-axis and the distance travelled in meters on the y-axis. And it says, use the graph to estimate the speed of the car at time 5 seconds. So we want the speed of the car at 5 seconds. So 5 seconds is here, so that's this point here. Whenever you've got a distance time graph like this, to find speed, you basically want to find how quickly the distance is changing with reference to time. Or in other words, you want to find the gradient of the line. Now we can't just by looking at it find the gradient of this point here. Instead, we need to draw a tangent. So again, this is a bit of a pain because I can't draw straight lines, but you would, with a ruler, very carefully draw a tangent to this. And we then calculate the gradient of the tangent. So, to calculate the gradient of a tangent, m, remember it's gradient, and I'm going to do the change in y. The triangle means change, so I got how much the y has changed by, divided by how much the x has changed by. So, if I think it's gone all the way up to here, it's basically changed, y has changed this much. It's gone from 0 up to 80. So my y-axis, or my distance, has changed by 80. And then my x-axis, my time, has gone from 3 to 8. So 5 seconds. So I just do 80 divided by 5, which I think is 16 meters per second. I do meters per second, sorry, because this is in meters. Like this is 80 meters. And time is in seconds. So it's meters per second. If it was kilometers and hours, then I'd have kilometers per hour. Yeah, like with these, you want to get this line as perfectly tangent as you can, but they do always leave you a bit of leeway in the mark scheme. So like this particular paper allows anywhere between 11 and 19. So you've got a fair bit of room in case your line is like a little bit off. Yeah, that's it. Oh, we didn't even need the units. They put units in for us. And that's it. Okay, so just zoom out a little bit here. Okay, so it says a darts team is going to play a match on Saturday and on Sunday. The probability that the team will win on Saturday is 0.45. If they win on Saturday, the probability that they will win on Sunday is 0.67. But if they do not win on Saturday, the probability that they win on Sunday is 0.35. Complete the probability tree diagram. So feel free to give this a pause and have a go. Okay, so with tree diagrams, basically they're showing you kind of all the possible things that could happen. So on Saturday, they could win or they could lose. Yeah, not winning is just, well, I suppose it could be a draw or losing. But we'll just say lose for now. So they could win or lose. Then on Sunday, they could win or lose again. And if they didn't win the first time, they could win or not win the second time. And just remember that for each column, the probabilities have to add up to 1. So like, if this is 0.45, this down here must be 1 minus 0.45, so 0.55. Because the idea is like it has to be one of them. You have to win or not win. You can't do both at the same time and you can't do anything else. So that's the one important thing to remember. The other important thing is just to put in all the information that you're given. So we're told if they win on Saturday, the probability that they win on Sunday is 0.67. So win on Saturday, win on Sunday, this bit here is 0.67. Yeah. Whereas if they don't win on Saturday, the probability that they will win on Sunday is 0.35. So if they don't win, the probability that they win on Sunday is 0.35. We'll pop that here. So we're just like adding the information from the question to our diagram. And then we just use that rule that they have to add up to 1 again. So this and this have to add up to 1. So I do 1, take away 0.67, do my calculator, it is 0.33. And for this one down here, we do 1 minus 0.35, which is 0.65. And that's it, we've completed our tree diagram. So, if we scroll down now, the next part of the question is find the probability that the team will win exactly one of the 2 matches. So exactly one of the 2 matches. So basically they can't win both, they can't win neither, they have to win only one. Alright, so if we scroll back up, we can kind of zoom into this bit. This is the only bit we care about now. So if you only win one, basically you could win the first, but not win the second. Or you could not win the first, but win the second. Like in either of those 2 cases, you've only won 1 out of 2 games. So if we think about this top one first, to win this and not win this, we have to do these probabilities. And when like 2 things have to happen sequentially like this, so in probability, when one thing and another thing have to happen, both one after the other, then you multiply together the probabilities. So we do the 0.45 times 0.33. And if you want, you can represent this as like a win times a not win. Sometimes it's helpful to kind of just put it in letters. And that, let me just put that in the calculator. 0.45 times 0.33. Oh, yeah, probably should have done that in my head. Is about 0.15. Yeah, so the reason I should have been able to do that in my head is because 0.33 is basically 1/3. So all you're doing is finding 1/3 of this, or dividing it by 3. And as 45 divided by 3 is 15, 0.45 divided by 3 is 0.15. Alright, then we've got this next one. So not win and a win, so we can do not win times win is 0.55 times 0.35. Apologies if you can hear the sirens. I live kind of close to a hospital. And we pop that in, 0.55 times 0.35. And this one gives us 0.1925. Okay, so we now have these probabilities. That's good. But that's the probability of winning and not winning, and then not winning and winning. If we want to find the total probability that he only wins one, or they only win once, we have to add these 2 together. So the total would be 0.15 times 0.1, I can't even read my own writing, 1925. My handwriting is quite bad on paper, so it's kind of even worse here. And that, sorry, should be a plus. Sorry, let me just correct this. 15 plus 1.195. Okay, so that's that. Then, sorry, not. So if I pop this in the calculator, 0.15, that gives us 0.3425 as our probability. And so we could leave it as a decimal like that, that's fine. Or we could put it as a percentage or something, but I think probability is probably fine. And also remember not to round anything. So I think I actually rounded this, which I shouldn't have done. So I should have kept this as a full answer and not rounded it at all. And we've got something very slightly different. But anyway, that's fine for now. Okay. I mean, you should really, yeah, I think leaving it to 2 decimal places would be fine anyway. So if we put 0.34, that'd be fine. All right. So on to question 16. So that's all the questions. So it says, on the grid, draw the graph of x squared plus y squared equals 12.25. So this one, you kind of, basically this is the equation of a circle. Whenever you see an x squared and a y squared in an equation together, it's probably the equation of a circle. And when you have, normally what happens is whatever you have on the left, it's going to be equal to the radius of the circle squared. You see there's actually quite a lot to unpack in a question like this. But the equation of a circle normally looks like this. So where x and y are your x and y, and then the a and the b would be the coordinates of the center of your circle. But you can see this one doesn't actually look like that. We don't have any brackets or a's and b's. And that's really important because that means that the center of our circle is at 0, 0. Yeah. So if it's just x squared and y squared, yeah, there's no brackets like this. It means the center is 0, 0. But the 12.25, that's equal to the radius squared. 12.25 equals radius squared. And so if you just want to find the radius of a circle, which you're going to need if you want to draw it, you're going to need a square root. So we square root 12.25, and that gives us 3.5. So if we just plot that now, basically 3.5 up here is 3.5, over here 3.5, over here 3.5, 3.5. And this is the center. So then I just draw my circle. Joining, oops, that's not a very good circle. But I was doing, yeah. So in exams, you want to kind of like, you'd rub that out and redraw it better. But that's the idea. Make sure you do go through all your points. This sort of thing would probably lose you a mark. So that's it. And then it says, hence find estimates for the solutions of the simultaneous equations. X squared plus y squared equals 12.5, which is the equation of the circle that we just drew. And 2x plus y equals 1. So this is a new line equation. So with simultaneous equations, you can solve them like algebraically, just working them out. But this says hence find. And whenever they use the word hence, they're basically telling you use what you've just done. So don't just start off and do it from scratch. Use your previous part of the question. So because we've already drawn this line, all we have to do is draw this line here and plot it and see where the two lines meet. So the first thing I'm going to do is just take this line and rearrange it into form of y equals mx plus c. And to do that, I'm just going to take this 2x on both sides. So I get y equals negative 2x plus 1. And that's really helpful because I've got this minus 2 in front of my x. So I know that m, the gradient, is minus 2. And I've got this here, so I know that c is positive 1. And that means that if I go up to here, I know that it's going to cross the axis, cross the y-axis, sorry, at 1, because we just said that c is positive 1, and that tells you the y-intercept. And because the gradient was negative 2, it's going to go down by 2 for every 1 that it goes across. So when I go across by 1, it's going to go down 1, 2. When I go across by 1 again, it's going to go down by 2 again. Or if I go the opposite way, if I went across the left by 2, it would go up by 2. So it's like that. Again, you want to get out your ruler and draw a straight line going through all this. And then you just look for the points where the lines cross. So they cross here, and they cross here. So these 2 points of intersection, where the 2 equations cross, these are my solutions. These are solutions to the simultaneous equation. So if we look at this, This one over here to me seems to be about 1.8. So if we go 1.8, and if you go across to here, it's maybe minus 2.6. Yeah. And if we go up to here, this one is, on the x, it's about minus 1.2. And on the y, it's about 3, maybe 3.2. I haven't left enough space there, have I? Minus 1.2, and then 3.2. Yeah, so these are my two coordinates. These are the two pairs of solutions. And I would just write these coordinates then down here. So I'd write all those. And that would be it. Again, there's a bit of leniency here because your circle isn't going to look perfect. Your line, your straight line should be almost perfect. Because if you put all the points and join them with a ruler, it will be perfect. But they give you a bit of leeway for your circle not looking quite right. Fantastic. Okay, number 17 then. So we're going to have to scroll out a fair bit here as well. Hope you can still see that. I know it's not ideal. So the histogram shows information about the times taken by some students to finish a puzzle. So basically how long it takes students to finish a puzzle. Here's the histogram. Yeah, we can see we've got time on the x-axis, frequency density on the y-axis. And for part A, it says complete the frequency table for this information. So basically, they've done the first one for us. So remember, to get frequency, you multiply class width, so like there's difference along the x-axis, by the frequency density. So for this one here, because we are, this is 5 wide, and it's 0.8 high, they did 5 times 0.8, yeah? 5 times 0.8, and that's how they got 4. For this next one though, it goes from 5 to 15. That's the difference of 10, yeah? Because 5 add 10 is 15, and its height is 0.4. So we do 10 times 0.4, which gives us 4 as well, just a coincidence. Next one, class interval is 10 again, but it's 0.6 high. So we do the 10 times 0.6 to get 6. Then this one, yeah, it's only 5 wide this time, but it goes all the way up to 1. So 5 times 1, which is 5. And bottom one, 30 to 50, that's 20 wide, because 50 take away 30 is 20, and it's 0.2 high. So 20 times 0.2 is 4, I hope. So, and that's that. We filled in our frequency table. Okay. Then down here on the next page, it says, find an estimate, hope you can read that, find an estimate for the lower quartile of the times taken to finish the puzzle. So an estimate for the lower quartile of the times taken to finish the puzzle. Okay, so with quartiles means like quarter, basically splitting your data up into quarters. So the lower quartile is basically like from the 25th percentile downwards, is the lowest quarter. So to find that, basically we want to think how many students did they test? Like how many students did they measure? So if we add up all of these, forward 4 is 8, add 6 is 14, add 5 is 19, add 4 is 23. So we've got a total down here of 23. So basically they asked 23 pupils. Now, if you want to find the lower quartile, you basically need to find like a quarter of this. But there's like a special rule where you don't just find a quarter of 23. You actually add 1 before you divide it by 4. Also because it's an odd number, that will make it 24. 24 divided by 4 is 6. So the whole point of this is basically saying if you have 23 pupils and you want to know like the lowest quartile, you're looking for the 6th person. So if you know how long it took the 6th person to finish the puzzle, that will tell you the time it took for the lower quartile. So next, what we have to do is think the slowest people were the 4 in this interval, weren't they? Yeah, so these 4 people, I'll just zoom in a little bit. So these 4 people who took between 0 and 5 minutes, these were the slowest. Yeah, and these 4, these were the next slowest. They took somewhere between 5 and 15. But we want the first 6 people. So the first 4 were all here. So we will include all of these and 2 of these. And if you think of the 2 compared to this 4, we're like halfway through this interval. Yeah, sorry if you're not entirely getting this. It's quite a big topic. It's quite hard to explain just for an answer. But basically, we're going to go halfway through this interval because we want 2 from this interval, not the whole 4. Yeah, and 2 is half of 4. So we just think, what is half of 5 and 15? What's halfway between here? Halfway between 5 and 15 is 10. So it's 10. Our answer overall is 10. So an estimate for the lower quartile of the times taken is 10 minutes. We're basically saying that if you were on exactly the lower quartile, or you were the 25th percentile, yeah, it would take you an average 10 minutes. That's what we can guess from the data. We're going to do a separate video on this topic another time, so we'll go over it kind of in a lot more detail if that didn't make sense. But hopefully you got that. Okay. All right, so we're getting to the end of the paper now. Only a few questions left. Getting quite tricky. This one here, it says that this thing is a cuboid. AB is this long, CH is this long, and so on. And we need to find the size of the angle between AH and the plane ABCD. So, with these ones, basically, you got this cuboid, and with these you can use, we're trying to find out angles and stuff. So, the size of the angle between AH and the plane ABCD. So, it's probably best to sketch that on. So here's H, here's A. So if we draw a dotted line between the two, it's not perfectly straight, but we basically want the angle between this line and this plane here, so this flat surface. So it's this angle here that we want. Yeah. Imagine there was a string going from A to H, and you want the angle between that string and the floor of the cuboid. Nicely though, this angle down here will be 90 degrees. Yeah, so this is 90 degrees down here. So if you, like we're not sure exactly how we're going to do it because we need to think about what numbers we're given. But if you want to find this angle and you've got a right angle triangle, you can use your SOHCAHTOA rules. And so if you want to use SOHCAHTOA rules, you need to know some of the sides of the triangle. Maybe the opposites, the adjacents, the hypotenuses, but we need to know some side lengths. So that's going to be our aim. Let's put what we know though. So we know that AB is 7.3. So this one over here, A over to B, this is 7.3. And we know C to H is 8.1. So C up here to H is 7.1. And then BCA is 48. So if we drew a line from B to C over to A, this angle here, BCA, would be 48 degrees. Okay, so it starts to look kind of messy here. When you're working with 3D shapes like this, what's normally best is to draw out the individual triangles that you have. So you see this triangle down here, yeah, the ABC one. There's going to be a right angle over here. So I could draw this out. We could draw this like this. Got a right angle over at B. We've got A over here. We got C here. this is 48, and this over here is 7.3. So I hope that makes sense what we've done here. We've taken this triangle that I've drawn in blue, and I've just drawn it as like a normal triangle rather than all this 3D stuff. And then if we can also do another one for A, C, H. So if you can imagine this here, we've got A, H, and C. Yeah, so from A to C to H. This is the other important triangle. Again, this one here is a right angle this time. This one here is 7.1. We want to find this angle. This is like our x, that's what we're trying to find. We don't know anything else. Okay, so all we've done so far, we haven't calculated anything. We've just put the information that we're given onto the drawing, and we've drawn our two triangles that are involved as 2D drawings. Okay, so as we said, this is the angle that we want. So to find that, you need to know one of these. Well, you need to know two sides. We already have 7.1, but we need to know one of these. But we can't find that directly. Instead, we're going to have to use this triangle over here. And if you notice, this side here from A to C, this is in both triangles. So we have AC over here and AC over here. So if we manage to find AC using this triangle, we'll know what AC is, and then we can use it over here to find X. That's our plan. So this triangle here, if we think of Sokotoa, I'll just write it up here. We got, just notice you can't see the B very well. Let me just pull this picture down. So yeah, this is, sorry, the B up here. Okay, so for Sokotoa, we have Sokotoa. And if you remember what that all means, basically it means that sine, yeah, so the is that sine equals opposite over hypotenuse. The ka is that cos equals adjacent over hypotenuse. And then the toa is that tan of x equals opposite over adjacent. So I've had to budget up a bit small there to get it. So if we think of this one, we want to find this length here, don't we? Yeah. And remember, this side is opposite the right angle. So this is our hypotenuse, and we know the opposite. So we want one with opposite and hypotenuse, which is this one over here, sine. So if we do our working, normally you would spread this out down the page, but I don't want to scroll. We got sine of 48 equals opposite, which is 7.3, over our question mark, yeah, over AC. I'll pop AC here. That's the hypotenuse. So to get AC by itself, I'm going to rearrange. I'm going to basically swap these two around. So AC equals 7.3 over sine of 48. Yeah, and I put that in my calculator. So what we've got is 7.3 divided by sine of 48. Make sure you put the 48 in brackets. And that gives me 9.8. And there's a load of other decimal places. So remember, in the exam, don't just use this. Like, do use all the buttons on your calculator. But yeah, so this is 9.8 up here. And more importantly, this over here is 9.8. What else we got? 9.8, 2, 3, 1, 2. Okay. So now we do the same thing for this triangle. Yeah, now we want to find this angle. And we have the opposite and the adjacent. So if we look out of these equations, the one that has opposite and adjacent is tan. So I know that tan of x, x being the one I want, is equal to opposite over adjacent. So opposite is 7.1 over the adjacent of 9 point so on. 9 point all this stuff. I'm going to just keep the button in my calculator, so I don't really need to write all this stuff out. And if I do that, remember when you want to find an angle, you've actually got to, I'll rewrite it, you've got to find to find x, I'm basically going to do tan to the minus 1. Remember, I have to press the shift tan button on the calculator. So tan to the minus 1 of 7.1 over 9.82, so whatever. So if I do that, if I do tan to the minus 1, just be careful when you put this in because it's quite easy to get messed up. Make sure you put your brackets and stuff. So that should, sorry, I've just realized that for this entire question, I've been using 7.1 rather than 8.1. My bad. If it was 7.1, then the answer here would be 35.9 degrees. But I should have used 8.1. So this should have been 8.1, like it says here, and this should have been 8.1. I've just copied it down wrong. So the actual answer, sorry, should be 39.5 degrees. That's what the answer should be. Just to say again, I got something different because I copied this number down wrong. I put 7.1 instead of 8.1. Sorry about that. Can't really go back now though. So hope that all makes sense. Sorry for my mistake there, confused you a little bit. But yeah, that's how we do it. So the main takeaway from this is just always think about what you have and what you're trying to find, and then kind of work backwards. And whenever you have a 3D diagram like this, write out the individual 2D diagrams because this is a lot easier to interpret. Awesome. Okay. So here, number 19, it says shape S is 1/4 of a solid sphere with a center of O. So this shape is 1/4 of a normal sphere. The volume of this is 576 pi, and we need to find the surface area of it. And hopefully we're given the equations. All right, so we've got volume, we need to find surface area. Now, the thing to think about these, and whenever you're given kind of circles and spheres and stuff, is you need the radius. If we know the radius, then we can easily work out surface area. Yeah. So if we give that a go, so this is the volume, and we know that the volume of a sphere is this. So volume equals, but this is the volume of an entire sphere. We only have 1/4 of a sphere. So it's actually just going to be 1/4 of 4/3 pi r cubed, yeah? Because we only have 1/4 of a sphere. Which, if we times that across, is basically just going to leave us with 1/3 pi r cubed. Yeah, you can just put 1/4 times 4/3 in the calculator, and it will give you 1/3. So if this is the volume of our sphere, which we know is this, we can then say that 576 pi must equal 1/3 pi r cubed. Yeah. So, because this is what the volume actually is, that's what we're told. This is the formula. So, we now just simplify this down. So we could cancel out these pi's. And to get rid of this third, we can multiply both sides by 3. And if we multiply both sides by 3, that will give us 1,728 equals r cubed. So now what we need to do is cube root both sides, and that will give us the radius. And if you cube root this number, it gives you 12. So the radius is 12 centimeters. Yeah. All right, so we've now found the radius, which is really important because now that we know the radius, we can start working out the area. So if we look at the area of this shape though, there's really two different parts. You've got this semicircle and this semicircle, which together basically make one entire circle. So to find that, we'd do the formula pi r squared. That's the formula of a circle. And then on the outside here, you've got the kind of area around the outside of the sphere. But again, we only have a quarter of a sphere. So it won't be this whole thing. If I just draw a line down the middle, it would actually be a quarter of this formula. Does that make sense? Because we're not, this area on the outside here isn't a whole sphere's worth of area, it's only a quarter of a sphere. So we've got to find a quarter of this, which is just pi r squared. So it actually ends up being the same as this, which is just a coincidence. So if we actually do that, I do pi times my radius squared. Remember, I know the radius is 12. So times 12 squared, which is pi times 144, or just 144 pi. And because it's the same, it must also be 144 pi. And so in total, yeah, the area of this and this added together, I just add these two together, 144 add 144 is 288 pi. Yeah. Now, that itself is sort of an answer, but they want it to three significant figures, not in terms of pi. So I do 288 times pi on my calculator, and that gives us, what have we got? 904. Oh yeah, it's just 904. So it's actually at 904.778, but because it's three significant figures, I have to round it to 905. That's it. Round up to 905 centimeters squared, but they probably give us the units. And that's it. 905. That's all done. All right. I think second last question now. Okay. So Martin did this question. Rationalize the denominator of this, and here's how he answered it. Martin's answer is wrong. Find his mistake. So we basically have to look through here and find his mistake. Okay, so the first bit that he did was correct. Basically what he's doing here is when you rationalize something, you multiply top and bottom by the denominator, but you swap the sign. So instead of having 2 plus root 3, we go 2 minus root 3 over 2 minus root 3. So that's what he's done here. He's put 2 minus root 3 in brackets here and here and multiplied it by the 14 and the 2 plus root 3. So that's all good. Second line, 14 times 2 is 28, that's good. 14 times negative root 3 is minus 14 root 3, that's good. Down here, 2 times 2 is 4, that's good. 2 times minus root 3, oh, he's actually done it other way around, he's done these two next. So he's done root 3 times 2 is 2 root 3. And then he's done 2 is 2 times this minus root 3 to get minus 2 root 3. That's also fine. And then he's done root 3 times minus root 3. And we multiply two roots together, you actually get the whole number. So root 3 times root 3 is positive 3. But because this is a minus, this sign here should also be a minus. So this is where he made the error. So find his mistake. So root 3 times negative root 3 equals negative 3, not positive 3. Yeah, that's the key mistake there. And that's all we'd need to write. Okay, so then, so this question, same sort of thing. So this time when we rationalize this, so again, we're just finding out where the mistake is. We've got 5 over root 12. So this is a bit different because it's not anything plus something. So for this, you just multiply top and bottom by root 12. Yeah, which she's done. Looks good. Multiply top and bottom by root 12. And then she went on the top, simplified the root 12 to 3 root 2. This is the wrong bit. So if we take root 12, that isn't the same as 3 root 2. Because when you simplify this, remember to simplify a third, you need to think of a factor pair of 12, where one of the factors is a square number. So we can rewrite it as square root of 3 times 4. Yeah, because 4 is a square number. That's the same thing as root 3 times root 4, which is the same thing as root 3 times 2, because the square root of 4 is 2. So, I just turn this around now, that just gives me 2 root 3. Yeah, if I have root 3 times 2, you have 2 of them, it's 2 root 3. So she wrote 3 root 2, when she should have written 2 root 3. Yeah. So I would just write this down here. I would say root 12 is actually 2 root 3, not 3 root 2. And that's it. Yeah, these ones can sometimes be a bit hard to do. I find if you can't see their mistake, just do the question yourself and see how your working is different to theirs. Because like they purposely make them hard, so it looks like all this stuff is correct. And to actually do it yourself, it's hard to find that mistake. Okay. Number 21, last question here. So it says here, Jackson is trying to find the density in grams per centimeters cubed of a block of wood. The block of wood is in the shape of a cuboid. He measures the length to be this, the width, the height, and they're all correct to the nearest millimeter. And he measures the mass to be 1,970 grams, and this is correct to the nearest 5 grams. So by considering bounds, work out the density of the wood and give your answer to a suitable degree of accuracy. Show all your working and give a reason for your final answer. Okay, so this is a kind of a very specific type of question. If you're not used to them, haven't done a few, they are a bit tricky. Basically what we need to do is we need to find the upper bound for the density, so the kind of highest the density can be, and the lower bound, the lowest density can be. And then once we have those two numbers, we need to see for how many significant figures are they the same value. Which might not make much sense, but we'll give that a go. So to find the lower bound, basically, so if you want, let's find the lower bound of the density. Yeah, if we want to find the lower bound of the density, then because density is in grams per centimeter cubed, we want to have the lowest mass divided by the largest possible volume. Yeah, so we want the lowest mass possible divided by the highest volume. Yeah. So the lowest that the mass could be. So think if 1,970 grams is only correct to the nearest 5, then basically you half the 5 to get 2.5. Yeah. And then you add and subtract this 2.5 from the 1970. So the 1970 can vary from 1,967.5, yeah, which is 1970 take 2.5, all the way, you could have it like this if you want, all the way to 1,972.5. Basically what I'm saying here is that the mass has to be somewhere between these two. Yeah. If mass was any lower than this number here, it actually would have been rounded down to a different number. It would have been rounded down to 1,965. And if it was any bigger than this, then it would have been rounded up. So we know that because it's correct only to the nearest 5 grams, it's going to be somewhere between these two. So the lower bound, the smaller number, is this one here. So it's 1,967.5. over the biggest possible volume, which we need to work out again. So basically these ones, we now need to go through and kind of find the upper and lower bounds of all of these as well. So the length, again, what you do is, because it's the nearest millimetre, or sorry, first of all, to find the volume of a cuboid, let's go back a little bit, you have to multiply the length by the width by the height. Yeah? So volume equals length times width times height. Yeah. So if you want the biggest volume possible, we've got to take the upper bounds of all these. If we multiply together the upper bounds of all these, that would be the biggest that the volume could be. So let's first of all find all the bounds. So because they're all correct to the nearest millimetre, we're going to have to do half a millimetre to get 0.5 millimetres, and then add and subtract it from all of these. Annoyingly, these are in centimetres, so if you want to add and subtract the nearest, so add and subtract half a millimetre, you need to add and subtract 0.05. Let's write this here, 0.05 centimetres. Yeah, because that is half a millimetre. So for the length, we take that away and we get 13.15. It's less than or equal to the length, which is less than, and then we add it on, we get 13.25. Yes, the length is somewhere between these, lower bound, upper bound. Then for the width, we have 15.95 is less than or equal to the width, which is less than, mind blank, 16.05. And then for the height, we have 21.7, take away the 0.05, is 21.65. Is less than or equal to the height, which is less than 21.75. Yeah. So these are my lower bounds now. And these are my upper bounds. So if I want to find the highest possible volume, I multiply all these. Yeah. So down here, I'm going to do 13.25 times 16.05 times 21.75. So this is the biggest volume I can have because this is like the upper bounds. Like this is the longest it could possibly be. This is the widest it could possibly be. This is the highest it could possibly be. And so by multiplying these together, that's the largest the volume could possibly be. So I put all this in the calculator. And just bear with me a minute. This will take a moment. Times 16.05 times 21.75. And that altogether gives us 0.42. It's really important that you write out like all the digits here. 5, 3, 6, 7, so on. Okay, probably don't need that many. Okay, so that is the lower bound of the density. Okay, that's the smallest that the density can possibly be. But if we try then to work out the higher bound of the density, so the biggest the density can possibly be, then we would need to do the largest mass divided by the smallest volume. So it's like, what's the heaviest it can be divided by the smallest volume that can be packed into, because that will give us the highest possible density. So this time we take this higher bound of the mass, the 1972.5, and we divide it by all of these lower values multiplied together. So 13.15 times 15.95 times 21.65. And again, I'll pop all of that in the calculator. So we've got 1972.5 over 13.15 times 15.95 times 21.65. And that should be kind of close-ish. We've got 0.43438. Okay, 3. All right, so this is the lower bound, this is the upper bound. So the point of all this was we can now compare these two answers to see what, like, how many significant figures they are the same to. So if I just scroll down for a minute, because we don't really need that, I'm going to write that my lower bound was this number here, 0.4253678. And my upper bound was 0.43438. So now that you've got both of them, you need to see how many significant figures are they the same value for each other, or at each other. So they both start off with a 0. They're both 0 point something. They're both 0.4, but then they change. I have a 2 and I have a 3. So these figures are not the same. However, if I rounded them, this would round to a 3, and this would round to a 3. So it's kind of like if I rounded them both to two significant figures, yeah, then this one here would be 0.43, or you say 2 decimal places. If I rounded them to 2 decimal places, this would be 0.43, and this lower one would also be 0.43. Yeah, so they're both the same. And that means that the density, we can measure accurately to 2 significant figures or 2 decimal places, and the answer is 0.43. Yeah. If we had tried doing it to 3 significant figures, yeah, this top one to 3 significant figures would have been 0.425, and this bottom one would be 0.434. So you can see how if you do it to 3 significant figures, they're not the same. So that you can't measure them to that degree. So what we've just found is that considering the uncertainties, or like the rounding from our units here, yeah, then it's millimeter and 5 gram stuff, the upper and lower bounds are the same value as each other to 2 significant figures. And so we can say that overall it is 0.43. We can be confident in that answer. And that's it. That's the entire paper. That took quite a while. I didn't think that would take so long. So well done if you kind of managed to the end there. We'll attach we'll put the actual paper and the mark scheme down in the description. And if you want the worked solutions, then of course just have a look through the video. I hope that was helpful. If it was, then please do let us know down in the comments. As we said before, we're doing a series of live streams on YouTube in preparation or practice to do some paid-for webinars. So if you'd be interested in more live streams or in the paid-for webinars, which we're thinking will cost maybe £2 or £3 each, then let us know. We'll also put an email or a subscriber list where you can sign up and you can hear more news about what we're doing. So anyway, hope you enjoyed it, and thanks for watching. Cheers.